Global warming is one of the most defining and important issues of our generation. You can see its consequences everywhere and all around the world. To help alleviate the outcomes of rapid global climate change, we should look to more unconventional and potentially risky methods to try and save the Earth. The idea of geoengineering utilises current and near-future technologies that are not fully understood to moderate the effects of global climate change. In this video, I will be covering 3 of these. Phytoplankton float within the upper layer of the ocean, and they absorb carbon dioxide for photosynthesis. Plankton only make up about 1% of the total plant biomass of the entire planet, yet these organisms fix between 30 and 50 billion metric tons of carbon annually, and alone count for about half of global photosynthetic activity. Looking at this map, you can see where there are dead zones. These dead zones are vast areas that lack significant plant life. So scientist John Martin discovered that despite the presence of adequate phosphorus and nitrogen, the oceans were missing a vital element, one necessary for the growth of plankton: iron. Iron is not a rare metal, the opposite in fact. In 2020, 2.4 billion tons of iron were produced globally, and iron alone makes up 5.6% of the Earth's crust, and is one of the most abundant elements on Earth as a whole. So if we were to deposit iron-rich dust into the ocean, we could stimulate plankton growth to make a significant increase in carbon fixing, and then begin to alleviate the damage of climate change. However, this method has many critics. In 2012, in an effort to replenish salmon and other nearby fishery populations, 120 tons of iron was deposited west of Haida Gwaii in British Columbia, forming a 35,000 km squared plankton bloom that lasted for several months and could be seen from space. Christina Yarda, an international legal expert, claimed that it appears to be a blatant violation of international resolutions. Furthermore, it contravened the UN's Convention on Biological Diversity, and as well as the London Convention on the Dumping of Waste at Sea, which both prohibit for-profit ocean fertilisation activities. In 1991, Mount Pinatubo in the Philippines erupted, resulting in a widespread haze, and scientists monitoring this event found that there was a global temperature drop by as much as 0.5 degrees Celsius in the next year. This global cooling period didn't last long, but using technology we could try to imitate and recreate this. Stratospheric aerosol injection is a form of solar geoengineering. It would aim to imitate this global cooling by releasing sulfur and reflective particles from high altitude balloons or aircrafts to help cool the Earth. You see, the greenhouse gases that we release traps heat, meaning that the Earth's temperature rises and causes global warming. By adding this new layer of aerosols, it will reflect the sun's rays and create a less devastating rise in temperature. Not only does this mimic a natural process, this method is technologically feasible. We do have the capabilities to do this, and at a relatively cheap cost. The annual cost of 5 million tons is expected to be from $2 to $8 billion. But the lifespan of these aerosols don't last long. Typically, they only stay in the atmosphere for 1 to 3 years, and it would require constant maintenance, just so we have the right balance. And if we didn't have the right balance, and one day we stopped without significantly reducing the amount of greenhouse gases we currently emit, the build-up of emissions over time would cause a climate catastrophe, and the Earth would experience possibly up to 10 times the current rate of warming, and therefore it should be recognised as merely prolonging the status quo and not actually fixing climate change. The UK aims to be net zero by 2050, and one major way it could do that is by utilising bioenergy and carbon capture storage, also known as BECCS. BECCS is the process of growing biomass such as wood and fast-growing energy crops, and then burning and converting this biomass into renewable energy. The carbon emitted from this process is then captured and stored in long-term underground storage, such as aquifers or dried-up oil wells. By absorbing and then storing this carbon, it allows for a net total of negative emissions. And by 2050, 53 million tonnes of CO2 could be removed per year in the UK from utilising BECCS. And we have plenty of space to put it. In the UK alone, there is estimated to be 70 billion tonnes of potential CO2 storage under the seabed. BECCS is a vital way of limiting global temperature rise, and possibly even necessary if the UK wants to be net zero. There are some drawbacks though. This only works if the trees or crops grown for BECCS were planted specifically for this purpose, and sometimes the emissions produced from processing, transporting and storing the biomass and the captured carbon dioxide will actually negate the carbon stored underground, and actually have a net positive result for the amount of carbon released into our atmosphere, making this whole process useless. There are many downsides to geoengineering. It could be used to avoid taking initiative and to detract from real solutions, as it offers a quick fix. It also takes away funding from methods that we know work, as many geoengineering methods are not properly understood. Stratospheric aerosol injection sounds like a great idea until you realise that it may endanger the food and water sources for over 2 billion people. And ocean fertilisation may have a worse effect for its environment, if even an effect at all. The land use needed for BECCS, of course, would displace food production, and it would use water and fertiliser that vulnerable communities may need more. Many scientists think that we're past the point of no return, and if so, we need to look at the potential methods on how we can fix the effects of climate change.